Alright, so inverse sine function. Y equals inverse sine, remember the notation, sine to the negative 1, just like inverse of f, f to the negative 1. So y equals inverse sine of x if and only if x equals the sine of y. And for the inverse, our x value has to be between 1 and negative 1, including those endpoints. And our y value goes from negative pi over 2 to pi over 2. And so remember, this is the inverse. We were looking at the graph of sine earlier, and we said we looked at the x value from negative pi over 2 to pi over 2. So the inverse, that's where the y value is going to be. So this is the key here. Inverse sine, whenever we do the inverse sine of something, our answer has to be between negative pi over 2 and pi over 2. Right? Or it can be negative pi over 2 or pi over 2 or anything in between. So we have the notation inverse sine where we have sine to the negative 1, or sometimes we can see it written as arc sine. Those are the same things, right? Inverse sine, whoa. Inverse sine, arc sine are equivalent. If we look at the graph of inverse sine, what's fun here? Remember, inverse sine, we're just looking at it from this part of sine, and for an inverse, we switch the x and the y's, and that basically flips it over the line y equals x. So when we do that, we end up with this graph. Again, going from negative 1 to 1 on the x-axis, and from negative pi over 2 to pi over 2 on the y-axis. For inverse cosine, y equals inverse cosine of x if and only if x equals the cosine of y. And for this one, again, x has to be between negative 1 and 1. And y has to be from 0 to pi. Like we were talking about earlier, for cosine, we looked at the graph of cosine, the x value went from 0 to pi. So in the inverse, the y value is going from 0 to pi. So when we do the inverse cosine of something, our answer always has to be between 0 and pi. And if you think about that, between 0 and pi, and I forgot to do this with sine, but 0 and pi, that's going to be in the first and second quadrant, right? So when we do inverse cosine, all of our answers come from the first and second quadrant. Inverse sine, we're going from negative pi over 2 to pi over 2. That is the first and fourth quadrant. At negative pi over 2 and pi over 2. So our answers, if it's in the fourth quadrant here, it's going to be a negative angle. Remember, because it's going from negative pi over 2 to pi over 2. A lot of people have a tendency to write the positive angle, that coterminal angle, that's positive, but it has to be between negative pi over 2 and pi over 2. And then our graph over here of inverse cosine, or arc cosine. Remember, this time the y value is going from 0 up to 1, 0 up to pi, and we're going from negative 1 to 1 on our x-axis. If we take this graph right here, just this portion, and flip it over the line y equals x, switch the x and the y values, we end up getting a graph that looks like this. And then our last one here, inverse tangent. y equals the inverse tangent of x if and only if x equals tangent of y. For this one, domain is all real numbers. You can put anything in for x. But our range goes from negative pi over 2 to pi over 2. But this time those values are not included like they are for inverse sine. Because if you look at the graph of tangent, the graph of tangent has asymptotes at x equals pi over 2 and negative pi over 2, along with many other spots. But the graph of tangent looks like this. We're just looking at this first interval from this asymptote, this asymptote. If we look at that part, that has an inverse function. And that inverse function looks like this. We've got horizontal asymptotes for the inverse function, and then our graph looks like this, going again from negative pi over 2 up to pi over 2.